Hi everybody, I've got an easy one for you today. The intermediate value theorem is what we're talking about today. So I'll go through the theorem. The theorem is going to look like it's complicated, but trust me, this is very simple, and it's actually a common sense theorem. So the theorem says if p of x, that's our polynomial, defines a polynomial with only real coefficients, and if for real numbers a and b, the values of p and a and p and b, so that means we have two numbers, a and b, let's say 1 and 2. If we do p of 1 and p of 2, and those answers are opposite in sign, then there exists at least one real zero between a and b. So if we take a look at an example again and go back to this theorem, it's a very easy concept to understand. First example, show that the polynomial x cubed minus 2x squared minus x plus 1 has a real zero between 2 and 3. First of all, you know I love to use my calculator to peek at things ahead of time if I can, because a picture is worth 1,000 words. So I've typed it in, and just go ahead and graph it. And you can start to see that between 2 and 3, you can see that it's crossing between the numbers 2 and 3. So I can already tell by looking at the graph that there's going to be a real zero between 2 and 3. A real zero, again, is where you cross the x-axis. If you don't cross the x-axis, the zero, the root, the solution, the x-intercept is not real. So remember, every time you see that word zero, it can be replaced with root, solution, x-intercept, or zero. They mean the same thing. It's where you cross the x-axis. So as the theorem suggests, we've got our polynomial p of x, that's this. We've got real number values a and b, that's our 2 and 3. So if we do p of 2 and p of 3, and the answers come out to an opposite sign, that means that there's definitely a zero there. So if we start our work here, p of 2 equals, replacing every x with a 2. And then we'll do the same for p of 3, replacing every x we see with a 3. And then, of course, we'll just do the math here. We'll have 8 minus 2 squared would be 4 times negative 2, negative 8, minus 2 minus 1. So p of 2 will come out to negative 1. Oh, that's a plus 1 there. So now if I do p of 3, 3 cubed is 27, 3 squared is 9, times negative 2 is negative 18, minus, oops, that should say a 3, my friends. That should be a 3. I replace the x with a 3. And plus 1. So if I do all that math together, that'll come out to 7. So as the theorem says, if the answers to this p of a and p of b, p of 2 and p of 3, come out to opposite signs, that means that there's a root there. So all that means, guys, if we just look back at our graph, it's saying when the x value is 2, the y value is negative 1. So 2, negative 1. When this x value is 3, the y value is 7. So between 2 and 3, if the y values are going from negative to positive, the only way for the y value to go from negative 1 to positive 7 is to cross over the x-axis. That's all the theorem is saying. So that's something that you guys would have thought probably anyways. It seems pretty obvious that if you're crossing the x-axis, that the y values would have to go from negative to positive. But that's what the intermediate value theorem suggests. So that's all for today. Your homework for tonight will be these numbers right over here. So go ahead and do those. The odds, of course, in the back of the book should be checked. And if you've got any questions, let me know. Have a good night.